Okay, so what we talked about today was we talked about this idea of covalent bonding. And this is where we are in the homework that was assigned. And what I like about this homework is it gives a good outline of how to do this, all right, along with this link that I showed you from class. But make sure that you understand how to use these prefixes. Right, that's what's going to go in front of every element, unless it's a singular one, but we'll get to that in a minute. And so know what numbers that these are associated with. Now, the one that is the most non-metallic, and the second rule here, is the one that is going to get the IDE suffix. Okay, so the IDE suffix goes with the most non-metallic, which means that it is going from left to right across the period, right? So as it goes to the right, it becomes more non-metallic. So chlorine is further to the right, as you see over here with the periodic table. Chlorine is further to the right than sulfur, so it is going to get the IDE ending. So we put that in there as chloride. And fluoride is further to the right than boron, so that becomes fluoride. Now, you have chlorine and fluorine. As it goes up and down the group, the higher up in the group becomes less metallic, more non-metallic. So fluorine is above chlorine, so that becomes fluoride. And carbon is above silicon, so then that becomes carbide. All right, simple enough. Now, if you have the first element, there's no mono for the first name, right? If there's only one of them, right? If there's more than one, then you go ahead and use a prefix, but you don't use the mono prefix ever for the first element. And as is written here, it is not it's carbon monoxide, not monocarbon monoxide. Now, this one, just make sure you don't have A or O doubled up, or A and O together, like here. That's more of a, you just have to watch how you write it. Not as big of a deal on 4. Number 5, if you have something like water, we just call it water. We don't call it its fancy name, dihydrogen monoxide. We don't call hydrogen peroxide, the stuff in the little brown bottle you used to get put in your cuts when you were little and fizzes up and hurts. We just call that hydrogen peroxide. We don't call that dihydrogen. Dioxide. We don't call ammonia, NH3, nitrogen trihydride. All right. So with just those 5 rules, keep those in mind. It makes this a lot easier, I think, than the ionic compounds. So here you have sulfur dioxide. That means you have 1 sulfur, and di means 2. So then you're going to have 2 oxygens. Here you have silicon and 2 oxygens. So that means silicon dioxide. All right. I have sulfur and oxygen. There's 3 oxygens. Sulfur trioxide. I have sulfur with 2 chlorine, so then that's sulfur dichloride. Notice that is the second one that always gets that IDE suffix. Now, on your paper, go ahead and finish this out and make sure that you have all this filled in, and that you know how to do that clearly. And then the homework that was assigned for today is also this sort of thing where you're naming the covalent compounds. Now, the other thing that we went over in class is that we started to look at this idea of ionic versus covalent. And I passed these notes out to you. Make sure you go ahead and star these 2 videos, because I tried to play the videos but I couldn't get the sound to work with doing it through Teams. So, and what I want you to do is to go ahead and outline both of those videos so you can get an idea of how this works and how what those 2 types of compounds compare in terms of their behavior. If we were in person, we were going to go ahead and do a lab on ionic versus covalent. However, obviously we're not, so we're not going to be able to do that. But so for next time, do the homework that's assigned. If you look in your homework section, it says binary molecular compounds, and watch these 2 videos and go ahead and take notes on them. And that's it. If you have questions, please let me know. And I look forward to seeing you on Friday. Bye-bye.